Okay, good afternoon. 4 more minutes. Good afternoon.
Good afternoon.
Hey, good afternoon. May I know for when can you see my slide now?
Yes, sir.
Yes,
can you
sir.
at the same time see me? Because I already turned on camera. Can you see me at the same time?
Yes, I can see your beautiful face, sir.
Not beautiful, but the slide is very beautiful. But how come I cannot see myself when I turn on the PowerPoint, and then at the same time, why I cannot see myself? Do you know how to set it? Anyone? Because if I cannot see myself, then no point to turn it on.
So perhaps you can minimize the Teams tab so that you show your camera.
I minimize team, you say?
Yeah, normally that will show the camera of the presenter or the speaker or whoever has the camera on.
Okay. I already minimize, and then okay, when I show the PPT, I minimize the Teams, and I show the okay, then I can see one of the students only, or then how to choose that so that I can see myself? You see, I can see only one student. Camera off already now. Okay. There's a stand up. Oh, it becomes like that. Can you? Let me see how.
This is okay.
So you are in a slide now.
But this one, I cannot edit. I cannot write on it if I choose this one. There's many options. Let me try another one. Let me try another one. Okay. Try another one. Side by side. This is only for me to present, I think, but I cannot write on the PowerPoint. This one also. Oh, then how come cannot? Spotlight. You will highlight your video for everyone in the meeting. Oh, okay. Spotlight.
Sir, maybe you could try pinning yourself.
How pin? How to pin?
Yeah, like you put at your profile, then there's 3 dots, then there is pin or fit to frame.
3 dot.
Yeah, if you click on your profile.
They are.
I think there's no such option for the user themselves. I know I cannot paint myself.
But in our staff meeting, I saw some other my colleagues, they can do that while they are presenting. If not mistaken, I think they can do that. I think must have somewhere to do. Oh, it's already 3 o'clock. Never mind. I think I set it. Trying to settle this. Find out the answer next time. It's already 3 o'clock. Okay, so let me unlock the Instead first. Unlock class. Okay, please sign in Instead now. Sign in Instead, and then so I think today we have 1 hour 30 minutes. I think I should be able to finish this chapter 2 today, and then I will. So after the class, I will post the video, the class notes, and also the tutorial questions for the chapter 2 to the Moodle, and then so the solutions I will release it next Monday. So again, that means if I can finish the chapter 2, so that means today, our quiz this Thursday will be covered until the chapter 2. Okay, until today's lectures. Okay, and I hope Thursday you can attend. All of you can attend the class on time, because I think I will spend maybe 5 to 10 minutes to brief you about this quiz. We will have quiz this Thursday, right, in the evening. So I will brief you. I will use 5 to 10 minutes to brief you what are the things which is important that you need to know. Okay. So now let me continue for today's lectures. For your information, the Q&A sections, the second sections, last Friday we have 16 students attend. So is in terms of number, it is better because first time 14, now second time 16. And also in terms of the discussion, I also quite happy with that, because some of the students they ask questions, and then we have also discussion. Actually, there's no any. I mean, in the responding the questions, actually we fully use the whole hours. So I think it's a very good sections. So I encourage those other students try to attend. Okay, even though you already know the answer, I think from the Q&A, that means your questions I answer. I think you may learn more, because your questions actually would trigger me to share more with you. Okay, so I hope you others can consider to attend the Q&A sections. Also, this Friday we have the sections 3. Okay, and so let me share this PPT. I already show you the PPT, so if you cannot see, please let me know. So we stop at the concept of this unit vector. So unit vector again, it is the vector with the magnitude of 1.
Sure.
Yes.
Sorry for interrupting, but you haven't started your recording.
Oh, sorry. Thank you for your reminder. Yeah, it's very important. I should not miss this. Start recording. Thank you. Already started. Okay. So this unit vector, actually, it is very useful, especially in the physics. In physics, Dr. Tan's class, you should already study IJK. But actually, the unit vectors can be built based on any general vector we have, because through the rescaling, we can make any vectors to become magnitude equal to 1. So, but the more common one that we use is the IJK. Okay, but anyways, for this first two chapters in our syllabus, part 2, mathematics for engineer, we won't focus or emphasize on these IJK things. Okay, so I give you one example, and already discussed with the solutions already posted to the Moodles as a class note. Now we continue for the additions of the vectors. I hope you still can remember the the structures of our lectures. Since we treat this as a new branch of the mathematics, whenever you start the new branches of mathematics, you have to start from the beginning. So that means all the basic concept, you have to check whether it is valid or not. Okay, whether it is the same as the familiar things that you learned before or not. For example, the scalar, you are very familiar with that, but not all the new mathematics in the new branch, they follow exactly the same rules for this scalar. So that means you must check everything from the basics. So now we keep on, we continue for our checking. Now is about the concept of the vector additions. How do you add the two vectors? Okay, if you know how to add two vectors, then you will know how to add 3 vectors, 4 vectors, 5 vectors. And the only difference is that the steps, the number of steps is different. You know how to add 2, you automatically know how to add the 3. Okay, but of course, to adding 3 vector, 4 vector, you need more steps. Okay, so again, vectors, it is to add 2 vectors, it is not the same as adding 2 scalar. The result that you obtain is not the same. Okay, also the meanings, the operations, that means the steps involved in additions, also not the same. So for vector additions, basically they have 2 methods to add up the vectors. Okay, in the graphical methods, we can show in this way. Now this law of addition requires a triangle law. Now let's say you have this vector, the first vector pointing horizontally to the right. Another one is pointing in the first quadrant. Okay, you imagine all these tails of the vectors, you can attach always. You can always attach a coordinate system, the origin of the coordinate at the tails. Okay, let's say you put a cross here, then the head would becomes. We can consider the tails of these vectors is attached to the origin of the coordinate system that we built. But normally we wouldn't sketch this. We wouldn't draw this coordinate x and the y axis. Okay. The reason I already mentioned, because any places you can put this vector to. So where is the origin actually is not important. That's why we don't draw it unless we need to know the coordinate as in the chapter 1. But now we do not need to know the coordinate. So the origin, where is the origin is not important. So if you have these 2 vectors, 1 and the 2, if you add it together, what is the step? The step is that you join the tails of the Now let's say I call this one as the first vector, this one is the second vector. So you draw the first vector first, let's say from the P to the Q. Okay, from the P to the Q, and then this second vector, the tails of the second vector, you join it to the head of the first vector. Now when you join them together, of course you must always maintain the directions and the magnitude of these 2 vectors. So this vector, when you move it here, you must make sure, you must make sure the angle with respect to the horizontal and the length must be the same. Can see, must be the same. Okay, this one horizontal vector, when you move it here, it must be the same, horizontal and the length also the same. So if you put these 2 vectors together, then you will get open-ended diagram, something like that. So now you draw the third vectors from the beginning point or the tails of the first vector to the head of the second vector. You join them, you get this PR. Okay, if I call this as a point P, point Q, and point R, then you get the PR as a resultant vector, or we call it as the net vector also can. Depends. Sometimes we call it a net, sometimes we call it a resultant. So in terms of symbols, we can write down like this: PQ plus the QR equal to PR. Can see PQ plus QR equal to the PR. So that means if you want to move from the point P to the point R, our destinations is the point R, but you want to starting point is P. You have to move to the Q first and then move to the R. So this is a special case. In terms of the diagram, we have these pictures, but in terms in symbols, then we have these equations: PQ plus QR equal to PR. So it means that this intermediate point can be anything. Okay, in this case it is Q, but it can be anything. It can be X. I put it as X. X means it's a variable. You can go to somewhere else and then go back from the P to some other places and then goes heads to this R. Okay, so this X can be any others points apart from the P and the R. So let's say now if I want to go to let's say now if I want to go from point P. From point P, I want to go to the point Q first, and then, sorry, not Q, let's say S, and then I go to the R, also can. You understand? So of course, then this equation, now if I call this point as the S, okay, this point as the S, then I would no longer get this first equation. What I can get should be PS plus the SR equal to PR. Can you see? For this case, it is PQ plus QR equal to PR. But for the second case, it is PS plus SR equal to PR. So that means to move from the P to the R, from P to the R, you can insert between this PR, you can insert the third symbol. Provided these two symbols are the same, you can make this PR into two terms. Becomes two terms, but the intermediate, the middle, we call it the intermediate symbols must be the same. In the first case is Q. In the other case, in the second case that I give you now is the S. But it can be any others points. Okay. So I want to emphasize this because later, without using the diagram, we will need to manipulate the symbols. When you manipulate the symbols, you must bear in mind that you can always change one terms into two terms by inserting any same symbol, any two symbol which is the same, to make it becomes two terms, and then between these two terms there's a plus sign. You understand? Let's say now if I give you the I give you another example without using the diagram. So now let's say in the tutorial you have symbols TS, a vector TS. It is only one terms, right? Only one terms. Now if you need to make it becomes two terms. Why you need to become two terms? This is a general discussion. It depends on context. Sometimes you need to make it into two terms. So if you need to make it into two terms and you need the plus sign at the between the terms, then you can always change the symbols to, let's say, TW, okay, plus and then WS. You can always add a third symbols between the T and the S. So this equation would be valid. Okay, so wait and see later when we discuss the example or the tutorial questions. I hope you can you will understand about this point. Now at this stage, I think it's quite abstract. Okay, so we come back to our main point for this this slide, where it is how to add two vectors by using graphical method. Okay, you join the head of the first vector to the tails of the second vector, and then you join the initial point to the final point. But when you join the initial point and the final point, you see the complete diagram you get is a triangle. That is why we call this equation, we call these ways of the adding the vector as a triangle law of additions. Okay. Now, if you do not want, in this case, in my explanation, I call this as the first vector, this one as the second vector. Now, this is the triangle law. Now I want to explain first another law, which is a parallelogram law of additions. Now, so this one again, I call this as a first vector, this one as a second vector. The process or the step is a bit different from this when we add up these two vectors together. Now we join these two tail to tail. So let's say now this is the first vector, I draw it here, and then this one second vector, I draw it here. So I join tail to tail. Just now I join head to tail. This one is join tail to tail. So you get this one PS, and then this one is the QS. So when you join it like this, then you have to draw another one which is parallel with the second vectors. You put it here, and then you draw another copy of the first vector, and then you put it here. So that means now you have a pair of the first vector and a pair of second vector. So the resultant vector would be obtained by joining the diagonal of this parallelogram. You join this diagonal, you get this is the resultant, PR. If you compare this diagram, which is a triangle, and this diagram, which is a parallelogram, now these two here composed of two congruent triangle. That means if this one you make another one, and then you put it at this side, at the left, then you get this parallelogram. Okay, so the ways of getting the resultant is different between these two vector. Now in this case, you join tail to the head to get the resultant. But in this case, you join the diagonal line of the parallelogram that you produce when you join the original first two vectors. Okay, so in this case, you can see in terms of equations, the PQ plus the PQ now plus the PS. After we have this diagram, we know that this PS actually is the same as QR, right? These two vectors are equal. PQ and the SR also equal. So, but originally, what we want to add up is the PQ plus PS. But this PS now I can substitute by the QR because PS and the QR is the same. So after you substitute this QR, you will see that this PQ plus QR, it will become the PR. So these steps actually is the same as this step. You can see Q and Q between two terms. Between two terms, the second symbols of the first terms and the first symbols at the second terms, when they are the same, then you can reduce these two terms into one by taking the first symbols in the first terms and the second symbols in the second terms. Okay, now this one actually this concept can be extended to any numbers of vector. Let's say I give you example. Let's say now you have this PQ. I use another symbols. Let's say TS SU plus UP plus PD. Okay, now you see you add up 4 vectors, but the result should be equal to T. Can see it. Because you see all the symbols, TS plus SU will becomes TU. TU plus UP will becomes TP. TP plus PD will becomes TD. So it will be, initially we have 4 terms. You can reduce it step by step from 4 to 3, 3 to 2, 2 to 1. Provided you, so that means you have to check, you see, all the symbols in these 4 terms, they have one pair, SS, UU, PP, except the first one and the first one and the last one. If you can see these properties, that means you can reduce it, you can reduce or simplify the expressions, okay? Because it involves the vector additions. So now these are the 2 rules of adding the vector, triangle law and the parallelogram. But triangle law would be more convenient because especially when the number of vectors is more than 2. In terms of drawing, triangle law would be easier. Okay, but of course I wouldn't ask you to draw. We will emphasize on how through the many symbol manipulations to solve the problem, not through the drawing. Okay, sketching maybe you need, but I mean the exact drawing no need. Okay, so now another point is that about this vector addition is that we know in scalar all the numbers they follows the commutation law. So that means 1 plus 2 equal to 2 plus 1. But is this true in vector additions? You need to check before you use it. You cannot simply assume, oh, they are the same, should be same as number. No, not necessary. Okay, keep in mind, all this checking we will repeat again in the complex number, in the matrix. You will see that some of the properties, they are the same as a scalar, but some they are not the same. Okay, so now how to check whether vector additions they are following this commutation law. A plus B, whether they are the same as the B plus A or not. So A plus B, if you use the triangle law, you can get this diagram, correct? A plus B, you get C. But B plus A, you draw the B first and then join the A. Now this A, the tails of the A, you attach it, you join it to the head of the B. So you get the C. You see in these 2 diagrams, the C will be the same. My drawing is not exactly the same, but I hope that in terms of idea, you can see that they should be the same. So if you want to check, of course, you can use your own paper and then protractors and rulers. You can simply assign the length and the angle for the vector B and the A, and then you follow these 2 steps. You go and check. You should able to get the C is the same. But of course, also you wouldn't get exactly the same by drawing, because it depends on how sharp is your pencil, how straight is your rulers, how good is your drawings skills, correct? So this is the reasons why in the physics and engineering also, in the end, we wouldn't rely on this kind of the drawing, because this kind of the drawing, it will produce the errors. So we will, in the end, we have to develop another system of the skills to use, which is more convenient and efficient. We call that method as an analytical method, which is involved the IJK, the unit vector. But this is not the things that we want to discuss for these chapters. Now, so if you combine these 2 diagrams, if I combine it, this one and this one, I will get this diagram, which is actually the same as this parallelogram. You see now A plus B and the B plus A should be the same as the C. So by triangle law, if you use these equations expressed in terms of equations, this OA plus the AC should be OC. Can see these 2 terms are same symbols A and A, then you can remove it to get the OC. But OA is what? OA is the vector A. OAC is the vector B. Then you get the OC is the vector C. Similarly, if you start from OB plus the BC, you get again OC. Again, you see this B and B is the same in 2 terms. So you can remove it to simplify to get the OC. So in terms of single letter, you get the B plus A equal to C. Therefore, our conclusion is A plus B is equal to B plus A. Proven. Once you have prove it, of course, now you can use this commutative law. Before you prove, don't assume that it must be true. This is the scientific methods. You cannot simply say that it is true. Follow your wish. Cannot. You must check. Okay. Now subtractions. Subtractions. What is the meanings of subtractions? We already know. Based on the addition, subtractions concept is come from the addition concept. By modifying some things. Okay, you can get the subtraction concept from the addition concept. So additions, we have this PQ. Let's say PQ plus QR equal to PR. Now in terms of diagram, I can draw this. PQ plus QR equal to PR. Now if you bring this PR to the right hand side, I'll get QR equal to PR minus PQ. Okay, but in this diagram, you see this is I call this as a A, this is a D, this is a B. So you get D is equal to B minus A. Or I bring these terms to the right, you get this one. So you see this, if you look at this diagram, this QR from the symbols, you know that this arrow must point from Q to R. Okay, this PR is points from P to R. This PQ is points from P to Q. Okay, so that means this B, the vector B, this vector B from P to R, so it points to the head of the D. This is the head of the D, R. And then this second term A is points to the tails of the D. This is a D. Okay, so this one points to the head of the D. This one points to the tails of the D. This is we have the minus sign again. How to change this QR? How to expand this QR into two terms, but between these two terms there is a negative sign? How to change? You can add any symbols, repeated symbols. Let's say in this case, QR, I want to make it into two terms. Then you can use any symbol. Let's say here I use P, and then the second terms, second symbols in the first term, I take the second symbols in this original vector, becomes PR minus PQ. Okay, in general, I write here QR equal to XR minus XQ. This X can be any symbols, but later in our example and the tutorial questions, the most common X that you need to use is not P. It's a special symbols. We call it as O. So that means later you will get QR equal to OR minus OQ. But I just want to remind you that this is not the only ways you can do. You can add this X, and you can put this X into any symbols. But what I want to emphasize is the most important thing is that you need to know to put this X as the O. Why it is O? What is the O? O is the origin. O is the origins of the coordinate system. Why the O is important? Later I will introduce when I will explain when I introduce another new types of the vectors to you. You understand? Okay. So what I want to explain now is what is the meanings of subtractions in terms of the graphical method. Oh, sorry. Let me charge my battery first. Okay. This one, I duplicate it here. Now, this D is B minus A. I can write this as a D equal to B plus negative A. B plus negative A. So that's why actually the negative, this negative A, we call it a negative vector. Okay, negative vector we already studied or not? Negative vector, unit vector, scalar. Negative vector we already studied, right? What is the meaning of negative vector? Negative vector means that the vector with the same magnitude but reverse in directions, opposite in directions. So now, if I modify these expressions and add a plus sign here, it becomes b plus a negative vector a. So now, if there's a vector b, this is a vector b. If I add b plus a, this a can see this a. Let me ungroup first. This a, I can put it here, right? If I add the a, I need to put it here, right? So I draw it as a red color. So b plus a, you should get b plus a. This is a resultant. But since now you want to minus, means b plus negative a. So this negative a, you have to reverse the directions. You reverse it, you get this. Okay, so you see the resultant, the result that you obtain also different. What you will get, you will get is this one, D, which is b minus a. This one is the resultant for addition. This one is the resultant for subtractions. Okay, I hope the key is that you need to be able to see the concept of subtractions. Actually, it's come from the concept of the addition. You are adding b with the negative a. So you're still applying the triangle law. So subtractions actually is a special case for the additions. This is a key. This is a key concept. Okay. Of course, before knowing what is a negative vector, you cannot do this subtraction. Okay, because when you write this b minus a into b plus negative a, you need to know what is a negative a. You need to define first what is a negative a. That's why before this, I have to introduce you first the concept of the negative vector. Okay. Next concept that we need to check is a zero vector. Now, what is a zero vector? A is a zero vector. A can be any. It is a symbol to represent any vector. We call it as a zero vector if and only if the magnitude of it is equal to 0. If magnitude 0, that means no directions, correct or not? Because there is no length. Where got the directions? Where can it point to any directions? Cannot, correct or not? So A is a vector if only if vector the magnitude is 0. So anything which is 0, then you can know that it is a zero vector. So now by triangle law, we know that we know that OA plus AA equal to OA, right? You see, I no longer use any diagram. We rely on the symbols only. OA plus AA, you check these two terms. You see the middle one got a pair of the same symbol, which is AA. Now, of course, this case is the same also in the last symbols, also A. So that means the second and the third symbol, you can remove it and then reduce from 2 terms to 1 terms becomes OA. But what is AA? AA is a point from the A and go to the point of the A. That means you go from one point to the point itself. That means you go nowhere. So you get 0 vector. So you get A plus 0 vector should be give you the vector A itself. So this is very, very similar with the scalar concept. So the 0 vector is similar to the 0 in the scalar. Because we know that any 0 add with any numbers, you will get back the same numbers itself. So this vector the same. Any vector you add up with the 0 vector, you'll get the same vector itself. Okay, and similarly, we want to know, you see, AA plus OA. Okay, AA plus OA. This OA, I can swap the positions. OA becomes AO. And then it becomes negative. Okay, it becomes negative, and I already says that just now. This one, you see, when the first 2 symbols same. Okay, then this is a minus sign. You can reduce it, becomes QR. Then you apply this to here. First symbol same, A and A, minus sign. So you can reduce it to OA. These two are very, very important. If you cannot apply this one and this one, then in this chapter's calculations, it will becomes difficult. So please make sure you understand. You can know this one, these two rules, these two equations. So since you have this, I can reduce at the right hand side for OA. That means AA again is the zero vector. When these two symbols are the same, then it is a zero vector because no length. Plus A, you get the A. So that means A plus 0 equal to A, 0 plus A also equal to A. The symbols, the positions of the zero vector is not important. Okay. Now, example, how to apply all this. Figure below shows the regular hexagons with the vertices A, B, C, D, E, F. You see, all these are following the anti-clockwise directions. And at the center O, this is the O. Regular hexagon, this is the keys. The properties of the regular hexagons is that all this side length is the same. All the angle is the same. What is the angle? 360, you divide by 1, 2, 3, 4, 5, 6, then each one is 60 degree. 60 degree, that means this one also should be 60, 60, because the side length is the same. So that means you can know that this regular hexagon composed of 6 equilateral triangle. And this length, let's say diagonal one, A to D should be 2 times of BC. B to E is 2 times of CD. CD is the same as AF. FE is the same as BC. Understand? So now by knowing these properties, now you can solve. The question asks you to find, express each of the following sums as a single vector. Single vector means that the answer is only one vector. Initially got 4, now reduced to 1. So how to solve this? Okay, now you have, we start from this, and then now I can group this AB and BC together and CD and DE together by using bracket. I use bracket. Why? You see, although all the vectors we repeat, but we already add the bracket. So the meanings of the first line and the second line they're no longer the same. So the bracket in mathematics means that you must handle it first, correct? So you must simplify it first. So now AB plus BC, we can apply the triangle law to get the AC. AB plus BC, you get this AC. So you should get a vector which is pointing in this direction, AC. And then CD plus DE. CD plus DE, you should get the CE. So this is another vector pointing here. Okay. So what is the resultant? Resultant should be AE. This one plus this one should be give you AE. So, sorry, I should write this one first. AB plus BC, you get AC, and then CD plus DE, you get CE. And then now CAC plus CE, you can apply the triangle law again to get the AE. So all these are due to the triangle law, because of the triangle law. Now this is an example. In the example, I show you all this diagram. In the solution, in the tutorial, in the test, of course, you have to analyze all this by yourself. Try to sketch the diagram if you really need it, okay? And then second one is to find the AB plus BC plus the AF. AB plus BC plus AF. Now, if using the diagram, then AF, sorry, this is AF. AB plus BC plus this AF. But this AF actually is a CD, same thing. So the answer is obviously AD, right? AB plus BC plus CD is the AD. Now, very simple, right? But provided the diagram is given to you. If there's no diagram, now you presume that there's no diagram. Now you cover up the diagram. You look at this, then you should know how to solve it. Again, now I group these first two vectors together. Because AB plus BC, I can simplify it to becomes AC plus AF due to the triangle law. B and B removed to get AC, And then this AC and AF, you see in the this second symbols in the first term is the C. First symbol in the second term is A. They are not the same, but this is the plus sign. So I should try to replace this AF by the CD. So AF by the CD, then I will I can satisfy the conditions to apply the triangle law. This is the equal vector. And then I apply the triangle law, I will get AC plus CF equal to AD. This is a triangle law. So in your solution, in your tutorial, try to explain every step as clear as possible. My styles of marking paper is that I won't only emphasize on final answer. If your final answer is right, but your steps and concept is wrong, then you will lose some marks. You cannot say that, oh, my final answer is right, then you should get full marks. No, I will actually more emphasize on this concept and your explanations. Okay. Now, next one. This is a vector expressed in terms of two non-parallel vectors. A, B are two non-zero and non-parallel vectors. Any vector OP in the plane containing A and B can express in terms of A and B. That is in terms of this form, where the M and N are constant. Now, what is the meanings of this non-parallel? I give you one example. Let's say now this is A. Okay, and then, sorry, I should not draw here because I already provide the example for you. Let's say this is two non-parallel vectors and two non-zero vectors. They are non-zero, they are not parallel. So any vectors OP, let's say any vectors can be expressed in terms of MA plus NB. M and N can be any number, any constant. Let's say any scalar. Okay. Example. So I need your imaginations. Apply your imaginations. Now let's say how to move from the starting point O to the starting point to the ending point at the head of the vector. How do you move from this point to this point? Okay. Every step you move, you can take A or B. Okay. So now, of course, you can, in this case, I can move it. I can move to the right first to a certain point, follow the A directions, and then I go back to the left and move up here, right? Because this is the directions of B. You can only follow the directions of A and follow the directions of B. So this is the good ways, good route to move from starting point to the ending point. So if this is the route to move it, then what is the length of this? Let's say the length is 3.5. 3.5 of the A, and then let's say this is the 4 unit of B. Therefore, this OP, this vector can be expressed as 3.5. 3.5A plus 4B. Then the value of M is 3.5. Value of N is 4. So any vector you can express in terms of any two non-parallel vectors. Okay. Another example. Let's say this is a vector for the first quadrant. First quadrant. Now I consider the second quadrant. This is the second quadrant. Second quadrant. Then I can also move to the right. This is this is second quadrant. Okay. I can also move to the right and then move to the left like this. Okay. But of course, this drawing is not follow exactly the scales. So you have to make sure the directions of B is the same as this vector. You can follow. You can get this is the vector A, and then you measure what's the magnitude, and then follow by the directions of B. Okay, and then you get the value of the M and the N. Now, how about this? This one, sorry, this one I think maybe should be this. I think is better. I think that just now one is not accurate. This one I think should be better. Should be this one. You move this one and then something like that. I think it's better this one. Okay. That means you will get the M value should be negative value. Let's say negative A or negative 0.5A plus, let's say 1B. Okay. And then how about this? This one, you can move it, let's say, to the left. Sorry. To the left. And then that means the negative A, negative something A plus negative B. Correct? This is negative B because B is pointing up to the left. This one pointing down to the right. Right to the right, downwards. So it is negative B. This is the negative A. Now, how about this? This one you can get how this one to the right first, can to the right, but you cannot move to the B, all right, correct? So cannot, I think cannot move to the right. How about move to the left first? You move to the left. Wait. This one,
So
how?
why not negative to B?
Which one first? Sorry, negative B. Yeah.
Yeah.
Negative B. Negative B maybe somewhere here. Depends on the exact one. Should be somewhere here, and then something like this also can. Okay. This is only concept. I hope you can see. You can see. The key is that any vector, no matter it is in the first, second, third, or fourth quadrant, you can express it in terms of any non-parallel vectors. The one that you have learned, which is the x-axis and the y-axis, you learn this since secondary school. Form 1, Form 2, you already learned this. This is a special case for this one. Correct? Because this x and y also is a non-parallel vector. It's non-parallel also, non-zero. And their angle between them is 90 degrees. Therefore, this is a special case for the things that we discuss now. Now we don't specify any angle between A and B. But for this case that you have learned before, it is 90 degrees. Okay, so what you need to do now is to extend your knowledge to include the more general case, to include all the non-parallel vectors. Okay, so maybe I cannot finish. I don't think I can finish today. Never mind. Now it's already 3:50, so I give you 10 minutes break. Don't worry, if that means if I cannot finish today's chapter 2, that means the coverage for the what you call it, the quiz will be less. Okay, 10 minutes break, please.
Okay, thank you, sir.
Thank you, sir.
Dr. To. Is it
Yes.
possible to move the slide to slide 26?
Can you speak louder? I can't hear. Hello.
Sorry, could you please move the slide to
Thank you,
like
sir.
the PPT to 26?
26. Okay.
Yep, thank you. I'm trying to take note.
Oh, okay. Get the OC. So in terms of comes OA. So again, you see this B and B is the same. To this subtraction. Okay, because when you write this B minus A into B plus negative A, you need to know what is the, and the first two symbols same. One terms becomes OA. But what is the AA? AA is a point from the, so A is the vector. Before this, I have to introduce you first the concept of the negative vector. Okay. Next concept that we need to check is the zero vector. Now, what is a zero vector? A is a zero vector. A can be any, is a symbol to represent any vector. We call it as a zero vector if and only if the magnitude of it is equal to 0. If magnitude 0, that means no directions, correct or not? Because there is no length. Where got the directions? Where can it point to any directions? Cannot, correct or not? So A is a vector if only if vector the magnitude is 0. So anything which is 0, then you can know that it is a zero vector. So now by triangle law, we know that OA plus AA equal to OA, right? You see, I no longer use any diagram. We relies on the symbols only. OA plus AA, you check these two terms. You see the middle one got a pair of the same symbol, which symbols reduced means you get 0. 0 is a point from the A and go to the point of the A. That means you go to one terms becomes OA. But what is the AA? AA is a point from the A and go to the point of the A. That means you go from one point to the point itself. That means you go nowhere. So you get 0 vector. So you get A plus 0 vector should be give you the vector A itself. So this is very, very similar with the scalar concept. So the 0 vector is similar to the 0 in the scalar. Because we know that any 0 add with any numbers, you will get back the same numbers itself. So this vector the same. Any vector you add up with the 0 vector, you will get the same vector itself. Okay, and similarly, we want to know, you see, AA plus OA. Okay, AA plus OA. This OA, I can swap the positions. OA becomes AO. And then it becomes negative. Okay, it becomes negative, and I already says that just now. This one, you see, when the first two symbols same. Okay, then this is a minus sign. You can reduce it, becomes QR. Then you apply this to here. First symbol same, A and A, minus sign, so you can reduce it to OA. These two are very, very important. If you cannot Okay, now it's already 4 o'clock. We should continue. Just for checking, can you see my PPT?
Yes, sir.
Okay, good, thank you. Okay, we continue. I give you one example to show you how to apply the non-parallel vectors. Now, in figure below, you see A, B, C, D, E, F. Again, anti-clockwise is a regular hexagon. And the AB is given as the vector P, and the BC is given as the Q. You see, this P and Q, they are non-parallel. They are non-zero, non-parallel. So any vector should be able to express in terms of the P and the Q. So question asks you to find, express the FD, CD, BE in terms of P and the Q. This is the first part. Okay. So FD first. You see FD. This is FD from F to D. It is the same as AC.
Tom,
right?
you're muted.
No, I'm not muted. Can you all hear me? Any others can hear or not?
Dr.
Yes, we
Todd,
can
can
hear
hear
you.
you.
I'm not muted. So continue. Then so this FD is equal to AC. FD should be same as AC. How do you know? Because this is the properties of the regular hexagon that I already explained just now. But this AC, you see, this is the A to C. It's only one term. I can make it into 2 terms because I want to express this AC in terms of P and Q. So I want now I want to change this AC into 2 terms by using the addition concept. So I can add this B, insert the B between them. I'll get AB plus BC. The rules, the equations, the 2 equations that I emphasized just now, very important. So AB plus BC. Now AB is P, BC is Q. Therefore, I will get P plus Q. This is the answer. Because the question asks you to find, in terms of P and Q. This is P and Q. At the right hand side, P and Q. Second one is the CD. Okay, C to D. But this CD, we can get this AC plus CD equal to AD. Let's say I choose this one. AC plus CD equal to AD. Now, I want to I want to remind you the solution I show you is only one ways of solving it. I never says that and then don't have the impressions that the solution given by your module convener is the only way. No matter what module, you must try to overcome. This is considered as a psychological barrier as a learner. You do not treat your lecturer's solution is the only way. But I cannot show you all the different ways. I can only show you one. So in this case, you may ask me why I choose AC plus CD equal to AD. Can I choose AF plus FD equal to AD? Can also, no problem. Can you choose AE plus ED equal to AF? Can, if you are able to find the answer, can, no problem. So please free your, make your, how to say that? Don't make yourself rigid. Okay, don't stick to my solution. Pay attention to the concept that I explained, because concept, once you know it, concept is not the rigid things. Once you know it, you will become flexible. After you study, my lessons, my lectures, and you become rigid, that means you don't get the concept that I try to pass to you. You understand? So don't stick to only one solutions that I offer. Okay, I propose. So now this is AC. I use AC plus CD equal to AD. But what I want is the CD. So now I change the CD as a subject. I get CD equal to AD minus the AC. But what is the AD? You see this AD, A to D is 2 times of BC, right? A to D is 2 times of BC. This is based on the properties of this regular hexagon. Therefore, this AD is equal to 2Q. But what is the AC? AC you already have here, right? AC is P plus Q. Therefore, the second line will change to third line. 2Q minus P plus Q. Then simplify it. You'll get Q minus P. This is answer. Only Q and P at the right hand side in terms of P and Q. The last one is the BE. Now you see, where is the BE? BE is this. Then BE should be 2 times of 2CD. Can you say that BE is equal to the 2 times of AF? Can. Okay, but now I only propose you one way to solve it is BE equal to 2CD, but it is not the only way. I never say that it is the only way. Okay, so then it will becomes CD. What CD you already have, all right? So you get this equal to 2 times the Q minus P. Okay, this is part A. How about part B? Now, given P is a unit vector, evaluate the AC. Evaluate AC. The question says that P the unit is a unit vector, means that the length of the P is 1. This is 1 unit. Now, if P is 1 unit, then Q must be 1 unit. Why? Because this is a regular hexagon. Regular hexagon, every side length is the same. This question very important. Please pay attention. Please make sure you understand, because many students make this mistake in the midterm test and the final. Okay, please pay attention. There's a very, very important point here involved in this simple example. Now, since the magnitude and P of the P and the magnitude of the Q must be the same, correct? Not because this is regular hexagon. Now, because given magnitude of P is 1, then the magnitude of Q must be 1. Now, you apply. You want to find this. You want to find this length. Evaluate the AC. Sorry, I should use this with the arrow one. You want to find this AC. What is the length of this vector AC? This is not the right angle triangle. Just now when I discussed this with you, I said Cartesian coordinate system I and J, this system is a special case for these non-parallel vectors. And in the first chapter, you already know how to evaluate the distance or the length between 2 points. You apply, let's say now you have a vector A equal to 3i. I hope I can use these symbols. Oh, okay, I use okay, the point, let's say, okay, I use this symbol I, 3i plus 4j, right? 4j. Okay, so this is the point at somewhere here. This is the vector. This is the vector. Now the question asks you, hey, what is the length of this vector A? I believe all of you know how to solve, right? This is vector A, 3 and 4. Or sometimes some system they just put as 3 and 4. Okay. How do you evaluate this length? I think all of you know. It is using Pythagoras theorem. 3 square plus 4 square, then sum it up, and 3 square plus 4 square, and then take the square root of the sum, you will get 5. These Pythagoras theorems only valid when the angle of the unit vector, you see this I and j, between I and j, they are perpendicular. You see, they are perpendicular. So you can apply Pythagoras theorem, but this one, in the general case, non-parallel vectors, they are not 90 degrees between them. You cannot use Pythagoras theorem. So in the test, I remind you, for those who absent, please tell them. If you use this Pythagoras theorem to evaluate the AC, a big cross for you, because from the beginning, you're already wrong. Although it is possible, because of luck, you got the right answer. Why it is because the luck you can get the correct answer? Because 2 mistakes will cancel out, becomes the right one. I always find that students, some students very lucky one. Their method wrong, their concept wrong, but final answer they can get the right answer. So many examples. So I hope that you understand. For those who absent today, please be kind. Tell them about this. Okay, so to find this AC, you cannot use Pythagoras theorem, but you must use the cosine rules to evaluate this, right? Cosine rule is what? This one. This is a cosine rule. I believe you know already in the high school. AC square equal to AB square plus BC square minus 2AB plus BC cos 120. This is cos 120. Still remember the regular hexagon? 60, 60, 60. So therefore, this one is 260 becomes 120. Okay, so you get this is 120. AC and BC without the because now this we are talking about the length, so there's no any arrows on top. So this AB, AB that is the length of the AB, then it is equal to P square, magnitude of P square plus magnitude of Q square, minus AB is the magnitude of P, BC is the magnitude of Q, and then cos 120. But what is the magnitude of P? It is 1. What is the magnitude of Q? It is 1. Then you substitute, you get 1 plus 1 minus 2 times 1 plus 1 times cos 120 is negative half. Negative, negative becomes positive. So 1 plus 1 plus 1, you should get 3. Oh, you should get 3. And then you take the square root both sides. You get the length of AC is the square root of 3. This is the length. Okay, if you want, you can write down the unit. Okay, because there's no specific unit given, then you can just put unit. If you don't put, also fine. So this example, the reason I give you this example is that I want to remind you that you cannot apply Pythagoras theorem if the non-parallel vectors that we consider is not mutually perpendicular. Unless this 120 becomes 90. That becomes 90, that means mutually perpendicular. Then you can use. So again, the more important things in terms of concept, if we put aside the calculations, the more important concept that I for today's lectures is that you must extend your knowledge boundary, okay, from the mutually perpendicular to the non-parallel vectors. This is a subset of the non-parallel vectors. Okay. Now, next point is about the positions vector. Now, positions vector is the vectors that I mentioned just now. Although I didn't use the terms, but just now I mentioned about the importance of the symbols O, which is the origin. You see, if we have a vector, you see the positions of a point P. If only single letter P means a point. With respect to origin O, let's say this is the origin O. And then a vector is pointing from origins to the point P. This is the vector that you construct from joining origins to the P. This vector, we call it as the positions vector. The other vectors that we mentioned just now, let's say other vectors got what? F, D, C, D, B, E. When you see the symbols, all these symbols, there is no any O. FD is not no O. CD is no O. BE is no O. AB no O. BC no O. So that means all these are not positions vector. Okay, positions vector is the vector that start from origin. Those is not start from origin, like the example that I mentioned just now, I list up just now, are called the general vector. So positions vector and general vector, what is their relationship? That is important. Now you look at this. A vector expressed in terms of position vector. Any vector you can express it in terms of position vector. In fact, just now we already have applied, but now I need to explain it explicitly to you. Now let's say this is a PQ. PQ, you see, is not. It starts from P and points to Q. This it is not start from O, all right? So this is a general vector. But we can always join the tails of the P to the origin, okay? O points to P, and then O points to Q. We can always draw any vectors, any general vector. We can always construct this diagram, starting the tails and the head join to the origin. So we can always form this equation: OP plus PQ equal to OQ. Right, OQ. This is the triangle law, and then PQ will becomes OQ minus OP. This is how we express any vector PQ in terms of the positions vector. Can see at the right hand side only got the position vector. OQ is a position vector. OP is a position vector. Don't treat this as the new stuff. I already explained it just now. This one. This one. I said if this X now you substitute by O, you will get the things that I explained now. QR is a general vector. If you put the O and the second symbols minus O and the first symbols, you are expressing this QR in terms of the position vector. And as I mentioned just now, this is very, very, very important skills that you need to know in order to solve the tutorial questions. Okay. So example, 3 minutes. Let me finish this example. Relative to an origin O, this is the origin O. The positions vector of the A, this A, and the B are A and B respectively. The C is a point such that OACB is a parallelogram, and the M is the point of intersections of the diagonal OC and the AB. Find the positions of C and M. Now you see the question normally they will mention this position of C and M means what? Means that you need to find OC and the OM. So if any one of you, those who absent, please tell them if they during the test they ask me, what is the meaning of position vector of C? What is the symbol? Sorry, I won't answer you during the test. Please ask me before or after the test, because this is the thing that we need to test you. So now let's say positions of OC, then at least you should know that we want to find the OC. Okay, but OC can be written as the OA plus AC, right? This is a triangle law. You add a pair of the same symbols in between. Use the plus sign. You get OA plus AC. Okay, but you see this AC actually is the OB. So I will get this. This is equal to OA plus OB. AC, same as OB. Therefore, I will get this is the A plus B. Now, this is the position vector. When it says position vector means that it must start from O. OC. Ask you to find OC. And then this is to find OM. But what is the OM? OM is half of the OC. How do you know? This is the properties of the parallelogram. This is the midpoint of the OC. Then, since you already know OC, then the answer should be half of A plus B. Okay, so now it's already 4:20. Two more, I think, last concept in this, remain one concept in this chapter. So because it is quite long, and then it involves a very important example, very quite long the example. So I think I don't want to continue. Do you have any questions so far? Do you have any questions to ask? You may sign in the Instead now. I already unlocked. So for the quiz, the question will cover until this slide 34. But as I mentioned before, you do not need to solve the tutorial questions for preparing this quiz. The reasons I set the quiz is that to test whether you follow the lectures or not. If you follow the lectures, you understand all the example, it is enough for you to answer the questions in the quiz. Okay. Yes, any questions? Sorry.
Just to confirm, right, for the subtraction vectors, let's say for this slide is CD, right?
Which slide?
This current slide.
So this current slide, yeah, this one. Oh, CD.
Yeah. So so for subtraction vectors, is it possible? I mean, it's just a matter of rearranging the terms. So can we write like negative this vector, negative A vector plus B vector?
Negative what? Negative A vector?
Like if it's one minus the other, right? So it's B minus A. But can we also just rearrange it as negative B plus A instead?
Can, no problem. Let's say like this CD. Sorry, can you see the slide, this one?
Yeah, I can.
This is the CD equal to Q minus P, right?
Yeah.
If you want, you can write negative P plus Q, no problem. It's the same.
All right, thanks, sir.
But anyways, from your questions, it triggered me some points that I hope I can emphasize. That is why actually the importance of the students asking questions actually is very important. You ask, then it will help me to remember the things that maybe I missed out or anything. Okay, so like this one, or maybe I hope I can add like this one. It means that let me ungroup this one first. It means that I can move this Q from the center. This is the center of the regular hexagon. Okay. This vector. Sorry. Sorry, cannot speak. This vector is a P, right? I can move this P to here. This tails of this vector now is I attach it at the center of the origin of the hexagon, and then this this Q, I can put it like this. This is the meaning of AC is equal to Q minus P. Q minus P, right? This diagram now is the same as the one that I explained just now in the Q. Wait, this one. D equal to B minus A. Okay, same thing as this one. Wait, where is it? Wait, where is it now? Same thing as this one. CD is the same as this vector Q minus vector P. I hope you can see these pictures. Like this FD. Where is the FD? FD should be points from F to D, right? So based on this result, actually it is equal to P plus Q. P plus Q, right? Correct? Because we can always translate the vector to any places, provided you maintain the directions and magnitude. The P now I move it here, the Q I move it here, then you get P plus Q equal to FD. That's why we have this result of calculations. Okay, this is I hope that you can see why I hope the students are willing to ask the questions, because if ask questions, then I can, from your questions, I can recall something, then I can add something to you. You will learn more. It's already 4:25. I think for those who already signed instead you may leave. For those who have question and willing to stay back, you can stay back. Okay, see you this Thursday. Thank you.
Thank you, sir. Bye bye.
Bye bye.